What is up, 7th grade? This is lesson 70. Our objective for today is what is and how do you find volume? Before we jump into volume, let's remember a couple things we've already learned. First off, length. So length is how far something is how long something is, and you just have units in length. So maybe this thing right here is 2 inches long because you have to go 2 inches in order to reach from here to here. So maybe you could talk about how far your house is. You're 8 miles from here or something. So those are just lengths, and we're just talking about in single units. So inches, feet, miles, meters, centimeters, etc. The next thing we learned about is area, and that talks about how many squares it takes to cover it. So for this thing here, it's 3 units tall and 5 units long. So notice that there's 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 15 squares to cover this shape. And then we realized that we could say, hey look, this length is 3, and this length is 5, and if I say 3 times 5, that gives me the 15. Or really, if we said 3 inches times 5 inches, 3 times 5 is the 15, and inches times inches is inches squared, giving us that 15 inches squared. The unit of measure of area is measured in squares. It takes 15 squares to cover that. So we can still apply that same thing here. We say, okay, it's 2 centimeters by 7 centimeters, so 2 times 7 is 14. So the area of this must be 14 centimeters times centimeters is centimeters squared. It takes 14 square centimeters to cover this rectangle. And it even works if we have decimals in there too. We'd still say 2.5 times 3, which would be 7.5 centimeters squared. So on this one, it would take 7.5 centimeters squared in order to cover it, or square centimeters in order to cover this rectangle. So now that we have that, now we remember what area is. Now we're talking about volume, which is talking about how many cubes. Think about if you're going to fill this room with Rubik's cubes, how many cubes would you have to buy in order to fill up the whole room? So the idea is, if you use a basic shape, maybe like this one here, is that there is 3 units wide, I will say 3 inches, and it is 2 units deep, 2 inches deep. So on that first layer, it would be 3 by 2, so it would be 6 on that first layer. Then you have to see, okay, well, how many layers tall can I go? This is, again, 3 inches. So notice there'd be 6 on my first layer, there'd be 6 on my second layer, and then there'd be 6 on my third layer. And so if I combine those together, that's going to give me 18 cubic inches. So if I had I said cubic and wrote squared. If I have little inch cube, maybe foam blocks or something, it'd take me 18 of those to fill up this box. Now again, if you notice, that's 2 times 3 is 6, times 3 would be 18. So our equation for finding the volume is length times width times height. Here's the length of it, here's the width of it, and here's the height of it. That will tell me the volume. And again, volume is always measured in units cubed, because we're talking about how many cubes it takes to fill it. So let's do a couple of the examples that our book gives us here. We could draw all over this if we wanted to, or we can just use this formula here. So 5 times 4, so that means that 5 times 4 is 20, so the first layer, I would need 20 cubes in order to kind of cover the floor. And then this is going to be 3 layers tall. So the volume of this would equal to 5 centimeters times the 4 centimeters. They give me the first layer, then I multiply that by its height, 3 centimeters. So 5 times 4, 5 centimeters times 4 centimeters gives me 20 centimeters squared. And I multiply that by 3 centimeters. 20 times 3 gives me 60. Centimeters squared times centimeters gives me centimeters cubed. So the volume of this box right here would be 60 centimeters cubed. Now we'll do one more. This is what we call a composite, because it's not just a normal like rectangular prism. Notice it's kind of two of them stuck together. So how we do that is we kind of cut this into two separate ones. So we're going to look at this orange one first, and then after that we'll look at this purple one. Then we'll find those two areas together. Okay? So first the orange one, I know it's 4 wide, and I know that the whole length here is 8, and the purple one right here is 4. So that means this must be 8 minus the 4. So that means this one here is 4 centimeters tall, and the depth is the same here and here, so it'd be 4 as well. So the volume of the orange one is going to be 4 centimeters, which is the width right here, times 4 centimeters, which is the length, the depth, and then by 4 centimeters, which is the height. So that's going to be 4 times 4 is 16 centimeters squared, times another 4 centimeters, and that's going to give us 64 centimeters cubed. So that's the volume of this orange piece up here. Now let's find the volume of this purple one. So the volume of the purple one is going to be the length times the width, so it's going to be 4 centimeters times 8 centimeters times the height, 4 centimeters. So the length, the width, and the height. So multiplying those, we end up with 32 centimeters squared for the first layer. Then multiply that by 4 centimeters, which is the height. And that's going to be 128 centimeters cubed. So that's the volume of the purple part. But they didn't ask for the volume of just the orange or just the purple. They asked for the volume of the whole thing. So I have to add those two together. 128 plus 64. 8 plus 4 is 12. 6, 7, 8, 9. So 192 centimeters cubed is the volume of that big thing there. You can see your homework here starts on page 492. You can do all of the practice set, all of them that are specifically from lesson 70, and then 8 more of your choice. Good luck, guys.